Lecture 13, Viscous Flow in Pipes. The learning objective of Lecture 13 and 14, identify and understand the various characteristics of the flow in the pipe. The second, discuss the main property of the laminar and turbulent pipe flow. Okay. The third, calculate loss in a straight pipe and various pipe system components. The last one is predict the flow rate in the pipes by use the common flow meter. Okay. To transport the fluid in closed conduit, okay, commonly called a pipe. So that is the pipe. It is of the round cross section. So this is we call the pipe, the round cross section, or the duct. It's not round, so this shape we call the duct for the rectangle shape. Basic components of the typical pipe system are shown in the below figure. We can see that, and various fitting, flow rate control device, and pump or turbine. Okay, that is, we show that this part is we call the straight pipe. Make smaller highlight. So this part is a straight pipe. Okay, and this part is we call the that's a straight pipe. This is a straight pipe. Okay, and the other fitting is the elbow here, T, and this is a elbow as well. And the other type is the pump and the gate here, and this is an inlet. Okay, and this is a pump. Okay, this is a part of the pipe system. General characteristic of the pipe flow. Basic concept for the pipe flow of water pipe assume that the pipe is completely filled with fluid being transported. Okay, that is the, see that is a full of the fluid here. Another case is the concrete pipe drain the rainwater flow without the completely fill the pipe. So this is figure, you can see that the fluid is some part of fluid. Okay, so it's not completely fill the pipe. Okay, and in this, for the pipe flow, if the pressure at the flow is because of the pressure P1 is greater than P2 in P1, okay, to make the flow occur. And for the concrete pipe on the right side, is the pressure is as atmospheric pressure. Okay, and in this case we can learn from the in lecture 17 about the gravity flow, or the not completely fill the pipes. For pipes flow, the main driving force, okay, to be the pressure gradient along the pipe. In this case is P1 subtract P2. For open channel flow on the right side, the driving force is come from gravity alone in the driving force. Okay. And for the flow in pipe, we discuss next about the laminar flow or turbulent flow. Okay. In this figure, show the sketch of the below figure, sketch of the Renault dye experiment. Inject dye into the pipe and water flow due to the gravity. You can see that we inject dye here. okay, that inject dye in this point. And for the small flow rate, okay, the dye state remain as well defined line. Okay, that is the one that the line state is defined line. Okay, in this case we call the laminar flow. Okay, for this stake line. And for the intermediate, okay, the flow rate, the dye state fluctuate in the time and space, and we call that intermittent burst. Okay, that is we can see that some intermittent burst. Okay, it's not smooth line, and irregular behavior appear along the state we call a transition. Okay, and the last one, for the last enough flow rate, the dye state almost become blur and spread across the entire pipe. Consider this is the dye state. Okay, in this case, it is we call the turbulent flow, and is it in a random fashion. Okay. And one thing that if we can do is experiment in this figure is this point A. We measure the velocity at the point A. If the velocity with time is like this, so we call the laminar. So it means the velocity is constant along when the time increase. Okay, but if there is some fluctuation, okay, we call transition. But if the velocity is have high fluctuation like this, okay, so we call the turbulent flow at that point A. Okay, to make you understand more clearly what is the characteristic of the laminar flow and turbulent flow.